I am using lost sales case from JMP to show how we can run a multiple logistic regression model. Under fit model, we pass status, which is response to Y. The three predictors, one of them part type is categorical. We'll add them to model effects. As soon as you add a categorical variable as response, the personality of the model will change to nominal logistic, and we run the model. Similar to multiple linear regression, we have the significance of factors on top, both p-values and visually the bars. We will find out that code is not a significant predictor, a very large p-value, but part type and time to delivery are significant predictors of the status. In whole model test, the p-value of the chi-square is very small, so the entire model is significant. We can find the R-square of the model, a misclassification rate, which is about 40%, and under parameter estimates, all those p-values, we can select any of these factors. For example, if code is not significant, we can select and remove it. From the top drop-down, can create confusion matrix. 136 cases were actually lost and predicted lost. 136 cases were actually lost and predicted as won. That's part of the misclassification rate. 85 cases won they were predicted as lost, and 193 cases won and predicted won. Under drop-down profiler, you can see the effect of changes on the levels of the predictors and how they can affect the other variables or the outcome. For example, here time to delivery. If I grab this vertical line and move it to the right, that means increasing time to delivery. You can easily observe that moving to the right will increase the chance of lost and decrease the chance of won. Something else happens when increasing time to delivery. Focus on the slope of the line showing the effect of part type. Becomes nearly flat. And that means on the higher levels of time to deliver, let's say you promised 180 days for delivery. It doesn't matter what part type is, the code will be lost anyway. We can save probability formula, which will add 4 columns to the data table. The log linear probability of won and lost, the sum of these two probabilities is always 1, and then the one that is more will determine the outcome. If probability of won is more than 50%, then the outcome will be won. Most likely status will be won based on the formula of the model. So is about the lost. If probability of the lost is more than 50%, the outcome will be lost. We can estimate the outcome based on given values. This model is based on 2 predictors, time to delivery and part type. So we need to enter values for both in a blank row to see what's the outcome, most likely status. For time to delivery, let's say we have 40 days and the part type is aftermarket. Estimate of the model is that the code will be lost. Now I will change that 40 to 20, and then the outcome will change to 1.